Let's work through another couple of examples of differentiation, but this time we'll use the Leibniz notation. So let's say we have got two functions, y of x is equal to x cubed plus 3 upon root x, and y of x equals 2 upon 3x cubed minus 3x to the minus 1, and we're going to differentiate these. So first of all, we want to put this in a form that's make it better for differentiating. So really we don't want any factors of x on the bottom line, we want everything on the top line. So that can be rewritten as the y of x is equal to x cubed plus, well, root x is the same as x to the power of a half, so 1 upon root x is the same as x to the power of negative a half. So then we could write it out in terms of the Leibniz notation. We would say that dy by dx is going to equal, and then we do our differentiation, so it's going to be 3x squared, and this is going to be, well, it's going to be, if I get the rubber out, it's going to be minus, because we get the minus sign up here, so it's going to be minus a half times the 3x, and it's 1 less than a half, so it's going to be minus 3 upon 2. So we can say that dy by dx is equal to 3x squared minus 3 upon 2, and that's x to the minus 3 upon 2. So we could rewrite that x to the minus 3 upon 2 in a different format, so we'll do that just now. Dy by dx is equal to 3x squared minus 3 upon 2. Now that becomes 2x to the 3 upon 2, so the 1 upon 2 is the square root, so it's going to be the square root of x cubed. So that's us done that differentiation. So it's just a little bit of practice in differentiation, and as you see, there's nothing really any different other than we're writing dy by dx as opposed to y derivative. But the dy by dx is the preferred option, and it's what you'll tend to see if you go on and do any mathematics, or more likely physics, and you'll see it written in this format. And it's a nice format because it makes a suggestion of a ratio, but remember, it isn't just a ratio. You're not dividing dy by dx, you're doing you're taking the limit as well, so it's a limit as the delta x tends towards 0 of the ratio. But that doesn't matter about that, we'll go into that whenever we look at some other stuff. So let's go and we'll look at the second one here. So we're going to have this here written out. It's already in a form that we can deal with here, so we can write that as dy by dx. And again, go ahead and try these yourself before I do them and see if you can get the right answer. So it's going to be 3 times 2, which is 6, divided by 3, which is 2x to the power of 2. And this is minus 1 times minus, it's going to be plus 3x to the minus 2. So we can say that our dy by dx is going to equal 2x squared plus 3 upon x squared. So that's another couple of examples of differentiation. So thank you for listening. I'll get you on the next video. Goodbye.